next topic of this lesson, that is unit number 4, is AC generator here. So generator, the name itself has that it can able to generate the electricity. So and it is also referred as a energy conversion device also, because it can able to converse the energy from mechanical energy to electrical energy. So this is also called as the generator. So in our day-to-day life we saw when the power cut is happened, so we are on the generator. So in factories, industries, so likewise according to their capability, the generator, that is the value can be changed. So in our home we are using the small type of generator we have to use. So in factories they are using the large type of, that is it can able to produce a large scale of electrical power. That type of generators they have to use. So like that, so this is the energy conversion device. So it can be able to convert the energy, so mechanical energy into electrical energy. So generally we have to refer the AC, it can be referred as a AC generator. So alternate current generator here. So or it may be alternator. So generator is also known as alternator. So it is a energy conversion device. So it can able to convert the mechanical energy into electrical energy. So according to their capability, it can able to produce a large scale and also the small scale electrical power also. So next we have to see one by one. First, principle, construction, working. So on before that, principle, diagram, construction and working. So and also it can be split into the two types of generator, single phase and also three phase generator. So let's see the principle of AC generator. So it can works under the principle of electromagnetic induction here. So here the electromagnetic induction, electric and also the magnetic field it may be have. So the relative motion between these two, that is electro and magnetic, that is conductor and also the magnetic field, which can able to change the magnetic flux that can be linked with the conductor. So it can be able to produce the EMF, that is induced EMF here, and it will also produce the induced current. So that current is called the, what is that, electrical energy here. So the magnitude of this induced EMF that can be given by the equation Faraday's law of electromagnetic induction, and also the direction. So the direction of the induced current can be produced by the using the Fleming's right hand rule here. So this is the principle we have to use. We have to find out the induced current direction by using the Fleming's right hand rule, and also the induced EMF is also calculated by using the Faraday's law of electromagnetic induction, and it works under the principle of electromagnetic induction by the relative motion of the conductor and the magnetic field. Then after completed the principle, next we have to see the diagram part. So diagram, so some of the parts that are used in this generator, the first one is stator and also the rotor. The stator, the name itself says it is a stationary part of this that can not able to rotate or anything it can happen. So in your 10th standard we are studying about that, that is a coil is there. When the fixed magnetic field is there, when the coil is only rotating inside the magnetic field, that can able to produce the electric power, that is electrical energy. So when the rotating, that is the magnetic energy, can be converted into the electrical energy. But in this higher classes you are going to study about the stator. Stator is a coil here. So here look like this. So there are number of windings over there that can be fixed in the given slots. There are number of slots is also there. So it can be fixed by the windings, that is considered as a coil here. It can be stationary, that cannot be able to move. In center of this we have to fix the rotor. A rotor means rotating. It can able to rotate. So it can able to generate the two fields over there, the magnetic field, north and south field. So that can be fixed in the rotor column. So it can, here the magnetic field can able to rotate. So that is called the rotor. And also, so this is the alternator here. So this is the covering of the stator and rotor. So inside this alternator So we have to fix the stator, and also inside the center part the rotor can be fixed. So this is the covering and also the covering part of the generator. That is also we have to named as a alternator, and also the two important parts are there. So first one is brushes and also the slip rings are used. So because of this slip rings, so here the two slip rings are there. So it can be used, it can be fixed at the rotor. Rotor contains the magnetic field. That is, this magnetic poles are magnetized by the DC source here. So the ends of the field windings are connected to the pair of slip rings here. In this slip rings attached to a common shaft, that is about the which rotate the rotors. So it can also able to rotate along the direction of the rotor also. The slip rings rotate along the rotor, right? So next one, to maintain the connection between the DC source and the field windings, the two brushes are used. So because of maintain this connection between the DC source and field windings, so the two brushes are used here for continuously slide over the slip rings here. So these are all the main parts which are used in this alternator or generator. Next we are going to see about the construction, all the fixation of the one generator. So in this generator we will see about the two types of AC generator also. First we will see the single phase AC generator here. So this is the diagram of the single phase AC generator. So already we discussed the parts of the AC generator here. They all the parts together fixed here and forms the single phase AC generator. In this single phase, so what's mean that the armature conductor are connected in series, so it form a single circuit. So single circuit which generates a single phase only. So induced EMF, and also hence it is called the single phase alternator. So here only one phase is there. That is, phases means the armature is fixed with the windings, and also north and south, that is one pair of a set of the single phase is there, that is north and south. That is the two poles are considered as a single pair of the magnetic field here. So here, so because of this it can able to produce the electrical energy here. So here the armature slot is there. In this slot the winding is takes place, and also stator core is there. Stator core is the outer area that can be able to covers the windings, and also inside it a rotor is fixed. So the rotor consists of a slip rings and also the brushes here. So this rotor consists of the two poles, north and south poles, and also it can be able to connected with the DC source. So that is on the and also connected to the slip rings here. So these are all the brushes. The two brushes is also connected there. These are all the parameters that we are used for this AC generator here. So now let's see the working of the AC generator here. So in this picture let us consider the stator, that is coil is consist of a, that is a PQ or S here, and also rotor consists of a north and south pole, that is the initial position here. So here the B vector represents the north, that is south to north. So and also it can able to rotate in the with the angular velocity omega. So the arrow symbol is also denoted as here. So working when the loop, that is the PQRS is the loop, that can be, it is stationary, so that cannot able to rotate. So and also the wind, that is a field windings are excited. So when the magnetic field is produced around it. So here, so in this working part, when the DC current is passes from the brushes, it can able to passes through the, that is field windings, that can be able to excited, the magnetic field is produced around it. So here the two field can able to rotate, that is the rotor can able to rotate here. The direction of the magnetic field passing through the armature, so that can be, we have to calculate using the Fleming's right hand rule. So and also here the first rotation can be takes place initially, the field magnet is horizontal. So at that instant, the direction of magnetic field is perpendicular to the plane of the loop, that is PQ or as loop. So in this position, the horizontal position of this magnetic field, the induced EMF is 0 here. So and also, so when the magnetic field rotates through the 90-degree, the magnetic field becomes parallel to the PQ or S, and the induced EMF is maximum here. So that is also for rotation 180-degree, the initial position. It can again it can be comes and rest in the initial position. So that is perpendicular to that coil and it becomes 0. Then for 270 it becomes parallel, then the maximum EMF is produced. And for one completion, that is 360-degree, so it again comes to the 0 position and it can be forms the full complete rotation. Therefore, so here the alternate positive and negative current can be produced. That current is called the induced current here. So because of this one complete that is one complete rotation, that is the mechanical energy, can be converted into the electrical energy. The electrical energy is also from positive and also negative. So alternate energy, that is a wave formation, sinusoidal wave formation, the maximum positive value and also the maximum negative value and comes to the rest position. So this is the sinusoidal wave and it is also referred as the induced current, AC current. So this is the working of the generator, AC generator. So this graphical representation represents the first position of the coil. So omega t is equal to 0 first at the time, and also you have to plot that value for induced EMF and also for the theta formation that we already discussed in above topic also. So that is the orientation of the coil. The same procedure here we have to use that, and also it able to form a sinusoidal wave here. That sinusoidal wave is referred as a induced current. So first induced EMF is formed. That induced EMF value is also we have to taken as the value of the induced current. That current is called AC current. So that is about the single phase generator. Now let's see the three phase AC generator here. So what is meant by the three phase means? So here the totally 6 slots are used. So that is 6 slots means 2 pairs slot contains the single coil. So for example 1 and 6, you see that 1 and 6, that slot considered as a coil 1, and also for 2 and 5, that is considered as a coil 2, and for 3 and 6, that is considered as a coil 3 here. So whatever may be, we have to taken as a coil 1, 2 and 3. So there are 3 coils totally we have to use. So that is considered as a stator here. So and also in center of that rotor is used. So because of the rotation of this rotor, so it may be changes the angle formation. So it can be the angle difference is 180 for a three coils. So first coil started from 0, then second coil may be started as in a 90-degree, and also third is also for a different angle. That is the different angle difference between these 3 phases may be a 120-degree for each coils. So this variation of also forms a variation of EMF, that is epsilon 1, epsilon 2 and also epsilon 3 with a time angle. So it also forms the 120-degree phase difference between one another. So this is also the 3-phase AC generator here. So here see the graphical representation. The initial position of the field magnet is horizontal and field direction is perpendicular. So that is for the coil 1. So in the single phase AC generator, when the field is rotated in the position clockwise direction, so here alternating EMF epsilon 1 in coil 1 begins a cycle. So from the origin, that is O. So and also the corresponding cycle for alternating EMF epsilon 2 in coil 2, it also starts from a A. So after the field magnet can rotate it through 120-degree. Therefore the phase difference between the epsilon 1 and epsilon 2 is 120-degree. And also for similarly epsilon 3 in coil 3, that is it also begins a cycle of at point B. after the difference of, that is for comparison of first coil and third coil, 240-degree rotation of the field. So that is the initial position here. So the 3 EMFs are produced in the 3 phases. So with the difference of phase difference of each and every one, that is for coil 1 and 2 120 degree, for 2 and 3 120 phase difference, and also for 3 and 1 120 phase difference, for 1 and 3 240 degree rotation, that is phase difference here. So this is the 3 phase AC generator. It can able to form a 3 phase of the induced current also it can be produced.